So hello and welcome to Pharma-info with Shubhashish. Now today the topic which I am going to cover here is heterocyclic compounds. This is as per PCI syllabus, Pharmaceutical Organic Chemistry 3, study of heterocycles, right? So today the compound which I am going to deal with is pyridine, and the topics under this particular heterocycle is overview, basicity of pyridine, synthesis of pyridine, reactions of pyridine, medicinal uses of pyridine derivatives, right? Now this in a single video I cannot cover each and every portions which are drafted over here. Rather, let me just split this one into 5 different parts and just present in front of you, right? So now without further ado, let's do one thing. Let's just start one after another, right? So in this video, and that means I'm talking about the part 1, right? I'm going to cover the first 2 portions, that is the overview as well as the basicity of pyridine. Now, so as far as overview is concerned, right? So if I just try to draw the structure of pyridine, right? Pyridine is found to be a 6-membered heterocycle, right? Now why it's heterocycle? Because all the atoms that constitute the structure of pyridine is not found to be same, right? Of course, mostly same, but we have an additional atom, or rather a heteroatom, that is nitrogen present over here, right? The way I am presenting pyridine, it's not a pyridine, rather pyridine in its saturated state. The moment I am putting this double bond, thus the structure has been completed, right? Now, so as it is clearly visible over here, this is a 6-membered heterocycle, and the heteroatom which is present in this particular cycle is nitrogen, right? So pyridine is as far as aromaticity is concerned, yes, pyridine is aromatic in nature because pyridine complies with the Huckel's rule, that is 4n plus 2. If I just see 4n plus 2 pi electrons, how many numbers are there? 4n plus 2 equals to 1, 2, 3. 3 into 2, 6. So n comes down to 1. So n is found to be a non-negative integer, on the basis of that only we can say that pyridine is an aromatic compound. Fine. So this is the first thing that should be taken into account. So pyridine is an aromatic compound, so aromatic at the same time with heteroatom. So to be more precise, we can call it as heteroaromatic compound, right? Fine. Now let's focus on nitrogen. And of course, since it's an aromatic compound, it should be a planar one, right? It should be a planar one. So we cannot say that pyridine can change its plane and all, right? So now let's talk about the basicity of pyridine, because since nitrogen is there, so the first thing comes in our mind that nitrogen is very much responsible for the basic characters and all, right? So now let's see that whether the basic strength is found to be immense, or it is moderate, or it is poor, right? So if I just see the lone pair location or lone pair residence, right, all you can find is the pyridine is having a nitrogen and nitrogen is having a lone pair, right? But we need to see that where exactly the lone pair is, or what exactly the lone pair is meant for, right? The lone pair, as we observed in case of pyrrole, that the lone pair was given to the pi cloud so that the aromaticity is getting complied, right? But right now there is no need for the pi electrons to get satisfied to comply with the Huckel's rule, and it must not require any kind of lone pair from the neighbors. I mean to say the neighbor is found to be the nitrogen, fine. So that is why the lone pair is available for the seeker, right? So it is the seeker that can get the lone pair from pyridine without disrupting what? The pi cloud, because this pi cloud is entirely meant for making the pyridine aromatic, right? Fine. So seeker means the one which can seek electron, and the seeker should be electron deficient, and the giver, since nitrogen is having a lone pair, it can act as a giver, right? Or we can say it can act as a donor, right? So anything which can donate its lone pair can be termed as a base. So thus we can say that pyridine is basic in nature, fine. Why? Because by virtue of its lone pair, and which can be given to the seeker, fine. So pyridine is basic. Now we need to see the strength of basicity. Whether can it suppress the basicity of aliphatic amine? Let's talk about that, right? So we are done with overview. Now let's move on to the basicity of pyridine, right? So as far as basicity is concerned, pyridine is base, fine. It can accept a proton, right? And thus gets converted to a charged ion, right? So that is your NH. So after accepting a proton, pyridine can get ionized to form what? Pyridinium ion, right? Chalo. So this is all about your basic character. Now let's talk about the strength of basicity, and in that very context we have to bring what? Another compound, that is your aliphatic amine. We need to undergo one comparative study so that we can get to know about the strength of basicity. Fine. So this one is a pyridine. Assume that this one is the pyridine. Of course, it's not an assumption, rather it's a confirmation. This is the pyridine, fine. Now all we need to bring here is an amine, right? Let's talk about primary amine, right? Let's talk about primary amine. Now in case of primary amine, the lone pair is found to be a part of sp3 hybridization, right? Fine. Why? Because there are four, 3 bond pairs and 1 lone pair, right? Combination gives us what? 4, and 4 corresponds to sp3, right? Now coming here you won't find pyridine. The nitrogen is in sp3 hybridized, rather it's in sp2 hybridized. Why? Because here the bond pairs are found to be 1, 2 and the lone pair is 1. So 2 plus 1 corresponds to 3, and thus we can say it is sp2. So in case of pyridine, the nitrogen is sp2 hybridized. In case of aliphatic amine, the nitrogen is sp3 hybridized. So in which case the S character is rising. So in this case the S character is found to be more than this. So percentage character is found to be more in case of pyridine, percentage character is less in case of aliphatic amine, right? So if percentage character is keep rising, what does it mean? That means the entity should not be flexible in giving its lone pair. Fine. So that means the electrons are found to be held tightly, okay, to the orbital. So, and that is why it cannot be readily given to the seeker. So, and that tendency is very much prominent in case of pyridine, because pyridine is having the sp2 hybridized nitrogen, percentage character is found to be more, and by virtue of that it is the electron that cannot be readily given to the seeker, and the one which cannot give its lone pair quite readily to the seeker should not have a strong basicity, right? So that is why pyridine is found to be less basic than amine, because in case of amine it is sp3 hybridized, percentage character seems to be lower, and as percentage character is found to be lower, what does it mean? The electron is not at all tightly held, rather it can be given to the seeker quite easily, and the ease at which the electron can be given to the seeker, it indicates what the strength of basicity. Thus we can say aliphatic amines are found to be more basic. Aliphatic amine is found to be more basic than pyridine. Fine. So this is found to be the final inference that can be drawn out of this discussion. Fine. So basicity, pyridine is basic. Why pyridine is basic? Because the nitrogen lone pair is there, which can be given to the seeker. Fine. Now as far as strength of basicity is concerned, pyridine is not found to be more basic than that of aliphatic amine, because in case of pyridine the nitrogen is sp2 hybridized, in case of aliphatic amine the nitrogen is sp3 hybridized. So it is on the basis of percentage character we can say that pyridine is found to be less basic, because the one which is having more S character is not ready to give its electron quite easily than that of the one in which S character seems to be lower. So that is why pyridine is found to be less basic, or aliphatic amine is found to be more basic than pyridine. So with that we are concluding what? The basicity of pyridine. So we are done with what? The second point, that is the basicity of pyridine, right? Chalo. So now so this is all about here this. Hope you have enjoyed the video, or rather understood the fact and file. Please do one thing, you can leave your comments here, because without finding any kind of comments and all, I cannot improve, or rather I am not in a position to know that what is the lacunae in my presentation and all, right? So that is why today for today this much, that means the overview and basicity of pyridine, right? And in my next video you can of course I can cover up the rest, that is synthesis of pyridine, reactions of pyridine, and if time permits, definitely I'll provide you the information about its medicinal uses, right? So with that I'm concluding today's session. Now hope to meet you in my next session, where I am going to deal with the rest 3 portions which are left with pyridine, right? So thank you. Please do subscribe my channels and put your valuable comments. Thank you.